Hey, just wanted to share this with everybody. This is just an example of how I have used AI to troubleshoot some antenna problems. Maybe it'll help you out. Stick around. So before we get into the details, let's just talk a brief overview of the subject of AI, how you might be able to use it. There's a lot of controversy and probably misunderstandings and whatnot. And I myself have not used AI very much at all. Other people embraced it immediately. And I'm just really starting to figure out how it might work for me and the types of things that I might like to do with it. So let's just start off by saying that I'm using it as a research assistant basically. And I think that's a lot of what and why it was designed for. So basically, instead of me typing into Google all of my questions one by one, and it's kind of like the rabbit hole kind of thing. It leads you from one to another, and some of the information is good, some of the information is bad. I'm using the Google AI platform, so what it's basically doing all that legwork for me. So it takes all the information that I put in, it searches all the information that's out there on the web, and then it just compiles it very quickly. So I'm still able to, sort through the information that I'm looking for, but it's just a big time saver in that respect. One thing you need to remember is they have a disclaimer at the bottom saying the use of this tool may include mistakes. So because that it is just compiling information that is out there, some of that information that may not be perfectly accurate. So remember, this is just a tool that compiles everything and basically boils it down for you. So what I'm going to be doing is, this is part of some research that I'm doing on a specific antenna problem, and I'm documenting that, and I will have a full video on that problem and how I solved it and stuff like that. But this is just part of the research, and I thought it was very important because this may cut down the amount of time and work that I have to do to get to the best solution. And I think this may be very handy for a lot of you, especially if you don't have an Elmer. I mean, obviously, if I had somebody that I really trusted that was very, very knowledgeable in how this stuff works, I could call them up, email, whatever. And there are those people out there. A lot of hams are just the nicest people, and they're willing to help. But not everybody has access to a person like that that can take the time and help you troubleshoot your problem. So let's take a look. So one of the first things to remember is the more specific that you can be, the better results you're going to be receiving. So I'm going to read the question. Let's see, I'm going to need to scroll up here. I'm going to read the original question. I got some results, and then I asked a follow-up question. So a lot of this will be me just reading what happened, but it may help you figure out how to use this feature. So my question, here's how I worded it. I am comparing the effects of two locations for a portable ham radio antenna. I have used an antenna analyzer to measure the differences. Compare the two locations and speculate possible reasons for the different results with the same antenna. And then I listed the results off my meter. So you have to set somewhat of a parameters of what you're looking for and some of the information. Then you have to ask it what to do. Compare the two and speculate possible reasons. So I'll just go through some of this briefly. The initial result. Based on the antenna analyzer results, the two locations have distinct differences in their radio frequency characteristics. Most notably, the resistance and reactance. The difference in the antenna's electrical properties can be attributed to the impact of the immediate surroundings, including good ground conductivity, nearby structures, and height above the ground. Now this is all stuff that I knew and fairly basic, but it does a good job of comparing, and then we're going to take a look at some possible solutions. So this is a nice thing if you're not sure what all these numbers mean, R and X and L and C. This is a pretty good description. So the resistance R value between the two, there's a difference. Location 1 resistance is close to ideal at 50 ohms for a perfect impedance match. The lower resistance in location 2 suggests more RF losses in the surrounding environment, reducing the antenna's efficiency. Okay, now what about reactance? So this is what they say. The reactance is the imaginary part of the impedance, indicating how far the antenna's resonant frequency is from the measurement frequency. A very low reactance at location number 1 means the antenna is nearly at resonance. Location 2, higher reactance, indicates the antenna's resonant frequency has shifted away from the measurement frequency. And now we get into L and C, inductance and capacitance. Both locations show positive reactance, which is an inductive effect. This suggests the antenna is electrically too short for the measurement frequency in both cases. However, location 2 has a much higher inductive reactance, indicating the antenna appears electrically shorter there. So the same antenna, the same measurements, the same height off the ground, but it's not physically different, but it's showing up electrically shorter. Now we move on to capacitance. The capacitive values shown by the analyzer are derived from the reactance. The negative capacitance at location 1 is a result of the inductive reactance dominating and does not represent the actual negative capacitance. The higher positive capacitance value shown for location 2 is likely an artifact of how the antenna analyzer calculates the combined L and C from the reactance and is not meaningful physical value on its own. So now we're looking for possible reasons. And this is all stuff most of us probably already know. The effect on ground conductivity. Okay, is it highly conductive or poorly? The height above ground. Now this is one thing where I had to go back and clarify, because the height above the ground was the same. Nearby conductive objects, reflection, okay, metal surfaces, power lines, buildings, and things like that. Loading, the difference in the reactive values suggests that antenna's interaction with nearby objects is different in each location. That was, kind of my whole thesis of why I was having this problem, and I need to use that information that I've collected to figure out some possible things I can do to mitigate that. Physical setup. Okay, so this is stuff, maybe use different radials or cables, or okay, I had to clarify that was all the same. So let's go down to my clarifying question and see what they came up with. So what I then put in was, considering all of the above information, the physical setup nor the height of ground had changed. The antenna is a vertical whip mounted on a vehicle with the feed point height of 8 feet, aka my van. What are some possible solutions for a better match at location 2? Okay, number 1, reestablishing or improving the ground plane. The vehicle's body is critical for a vertical antenna acting as a ground plane. A poor connection between the antenna mount and the vehicle body can compromise the ground plane. So I have checked that. I know that has not changed, but this is just a good thing to make sure you got all your bases covered, because things can change in your setup if you don't check them. Inspect the mount, good idea. Bond the components. Now my van is very much one piece of metal except for the doors, and the hood is very small, so I don't think that's going to have a huge effect. Like say you had a sedan with a large hood and a sizable trunk, like if the trunk and the hood are not bonded and making a good ground plane, I can see where that could be a pretty big problem. Okay, here are some other things that we have thought of before. Tuning the antenna. Lengthen the whip. Well, my whip is maxed out there, and I even have used a longer whip and gone to where it is definitely too far and not been able to bring the SWR to where I want it. Tune with the loading coil. So if we're using a loading coil, we could use that. Add a capacitive hat. Yeah, I've tried that, and that did help some. So this is just like as far as the physical antenna, some things we can do. Simple step, using a tuner. Okay, yeah, it's kind of a no-brainer, but it talks about an automatic or a manual tuner. Changing the antenna type. Maybe this just is not a good antenna for the environment, and as much as we would like to use a certain antenna, it's not always possible or ideal for every single environment. That's why we have different ones. And then number 5, and this is probably what I'll end up doing. I've done some experimenting here. Since the poor match is specific to location 2, you may need a solution tailored to that site's characteristics. Number 1 suggestion, add a temporary ground radios. If possible, lay out a few ground radios on the ground near the vehicle to improve the ground system's effectiveness. This could improve the ground conductivity and raise the real part of impedance. Number 2, move the vehicle slightly. Even a small change in position a few feet can sometimes be enough to move the antenna away from a metallic structure or the object that is causing the problem. Yeah, and I have seen this. I have seen, just depending, even parking it like in my yard, I have seen the same thing with about 20 feet difference go from like a 1.09 at 14.05 to a 1.5 or 1.55. So this stuff really can make a big difference, and that's what the follow-up video will be going into, some of those details. Number 6, isolating the antenna feed line. So checking your feed line. Maybe you have to add a choke. That's another thing. I do have a choke. I've always run chokes, but then you could have a problem with your feed line. And then from there you can go on to dig deeper if you want to. You can type in your own follow-up questions or go to one of these. But I hope that helps somebody out there, because this just cut down a whole lot of time for me, and I'm probably going to be using something like this in the future, especially when I have, a lot of different numbers. So what I was doing, I could see the numbers of R and X and L and C, and I just starting to understand how all those things work together and what those numbers mean. How if I have too much of one or not enough of another, like what are the proper things to do. But this really sped up the process and gave some great suggestions by taking that data that I got from my analyzer and putting in some possible scenarios of how we can deal with that. Well, until next time, keep an eye out for that video. I'm sure, like I said, I'll be going into detail of how all of that panned out, but I appreciate it, and thanks for watching. 7-3, you've watched yet another ham radio video.